Okay, this section is all about modeling compound interest, right? Interest compounded annually. This is often called simple interest. Simple interest says that, every time you get to a end of a period of time, very often a year, right? Then we add interest, and then over the next year, you don't get interest until the end of the next year, and so on. So the formula is, we've got the value in relation to time is equal to a start. We call this the principal. 1 plus the amount of interest you're gaining over time. And really, it's that easy, right? So I could say, hey, the value over a period of time is equal to my start. Well, let's find this one. Someone invested $3,500. That is our start. Times 1 plus, looks like 3% annual interest, 0.03 over a period of time. All right. And down here it says we want to see when it reaches. I see there's a little bit more up here, but when it reaches $10,000, where our output is in. So let's go ahead and pull this up. All right, I'm just going to put it in this calculator just like I did, and we'll do two things. All right. Delete some stuff that we did today in class. Alright, we'll put this equation in. So the amount is equal to 3500 times, I can either say 1 plus 0.03, or I could put it in there, right? Uh-oh, put the wrong side in. 1.03 and parentheses raised to the x. Now we can do a number of things from here, right? I can go to my table. Let's do my table. Come on. I did the wrong way. I can go to my table, and I can plug in 5 if I have it on. Oh, I don't have it on the right one. Let me back up to 5. I could also just set this on, I'm just going to go ahead and do it. Table set. We're going to put our x value, our independent on ask, and go back to table and plug in 5 years. Looks like we got about 4,057.5. So I'll say V of 3 is 4,057.5 dollars. Let's go ahead and answer this question here. We go in there and we say, hey, let's set this equal to 10,000. Say enter. Make sure our window goes that high. I don't need my x values to be that high, so I'll go from 0 to, I don't know, let's try 15. That might do it. If not, we'll go back in. We'll go from 0 to 12,000 to cover what we need, and we'll graph this. Ooh, I don't think it's going to reach it, because that's going to be way at the top. Might have to go a little bit longer, because we can see that 10,000 coming across. So we're going to add to the x values. I'm going to bring it out this way a little bit. We go to the window, and let's bring that to 30 and see if that'll reach it now. So here it comes. It's going to start arcing up pretty soon. It's going to be more severe. It's going to, oh, maybe, but we didn't get it yet, did we? So change our window. Let's go to 40. This is going to do it for sure, except if I hadn't put 4, that would be awesome. Go back to that window and say 40, and we'll graph this. Here it comes. Moving across, and here it comes, and definitely intersects. So I'm going to go second calc, find out where they intersect. I'm going to go up here, move in, go to where they cross, somewhere in there, and push it 3 times. 1, 2, 3. Looks like it'll take 35.5 years. So I'm going to say approximately 35.5 years. So there it is. Alright. So simple interest. You just got to start, and then how much over 1 that you're growing each year. So if a person invests 200 and gets 6.5 annual interest, find out. So here we go. V of t equals, now we've got 200, right? It's growing at 1 plus, oh, it's 0.0625 to the time. Alright, so we're just going to plug that one in too. We're going to go right here. Let's clear that out and that out. I'm going to say, hey, 200. Alright, let's read that. And then, what is it? 1.0625. And raised to the x power. And we'll go back to our table. It says find the value when it's doubled. Okay. Oh no, that's not it. It says estimate reaches 5,000. So let's just go in here and we'll set this equal to 5,000. 5,000. Is it really 5,000? Oh my goodness, this is going to take a long time. We'll try this without changing our window. Starting to arc up, starting to arc up. No, not happening yet, because 5,000 is way up there, so we're going to bring our window out even more. Let's go bring our window to 60 years. How long does it take $200 to reach 5,000? Long enough for your grandchildren to earn the money, apparently. There it is. Let's go. Second calc. 5 intersect, and we're going to move over until they touch. Wow. And it looks like it takes about 53 years. So I'm going to say approximately 53 years. Let's go ahead and do at least one more. You know what? I'm going to skip C and come to D. You try C. You should be able to pull that off. Let's see. Bob invested $2,000 in an account that earns that much interest. All right, so let's do it. We got V of T. We start at 2,000, and it earns 1 plus 0.025. Maybe I should have said Bob of T, B of T, but to the x power. Betty. Well, there's another B, but I'll use B for Betty. Betty of T equals 2,300 in an account that earns a little less interest, right? So hers earns 1 plus 0.021 interest. Find when Bob is obviously going to overtake because it's growing faster. We're going to find out when it equals the value of Betty's and find the common value of the investment at this time. So let's do it. Alright, so we're going to go here. I'm going to clear this one out. We're going to put in Bob's, which was 2,000 times 1.025 raised to the x power. Right. And Betty's, I think, was 2,300 times, what was hers? 1.021 raised to the x power. I'm just going to let it grow. I'm going to see what happens if I just use the scale I have right now to see if they ever touch. There's Bob's. Right. Haven't changed my window from the last one. And it looks like they cross. So I'm going to make my guess. Here I go. Second calc. Intersect. And actually it looks like I'm pretty close to where they cross. I would guess in here somewhere. I'm going to hit enter, enter, enter. See if they find. Looks like 35 years they cross at 4,834. So we have 35 years at $4,834. We'll put it like that. Alright. A little Y there. And there it is. Alright. This is the easy one. Sorry it took so long. I want to do the next one. And we'll keep going.